March 30th, 2017 was a day that likely shaped space exploration forever. What is really remarkable is that nothing particularly special happened in space that day. But here on Earth, SpaceX made aerospace history by launching and landing a used rocket. You see, prior to this, rockets could only be used once, which made going to space really expensive. Can you imagine your car being destroyed every time you drove it, forcing you to buy a new car each time? That would severely limit your ability to travel. In space, we have big plans, but need many different technologies to reach our goals, kind of like building blocks. One of our most exciting goals for space is asteroid mining, which is the use of raw materials from asteroids and other near-Earth objects such as minor planets. The primary goals are to bring some of the materials back to Earth for economic advantage, as well as to utilize other materials in space to encourage further space exploration more generally. Precious metals such as gold, silver, and platinum could be transported back to Earth. This not only brings financial gains to the companies that retrieve them, but may also help increase valuable resources that will become exhausted here on Earth. Other metals, such as iron, hold the potential for extraterrestrial manufacturing. Believe it or not, water in space is also extremely valuable as a fuel, a propellant, a human consumable, and as oxygen for ships. Gaining access to these materials in space would facilitate further space exploration and discovery.
As mentioned, asteroid mining relies on the combination of many other technologies in order to succeed. These other technologies include how we get into space from Earth, mining, mineral processing, and returning to Earth. First, how do we get a rocket into space? Remember SpaceX? Developing reusable single state to orbit, or SSTO, rockets to replace one-time use rockets would drastically drive down the cost of travel to space. While we aren't fully there yet, we have taken important steps. Once we get to space, we need tools to mine and extract minerals from the asteroid. Many of these tools are similar to ones we already use on Earth, while others are being developed to deal with the unique challenges of space. Please check out the mining and extraction information on our module to learn more about the specific tools at play.
With a technology as complex as asteroid mining, there are a lot of different stakeholders, often with competing interests. Policymaking requires an understanding of each of them individually and how they will work or not work as a whole. Many governments have a vested interest in space with robust programs to support this, such as NASA. In April 2020, President Trump signed an executive order to support moon mining and to tap asteroid resources. This is in addition to a law Congress passed in 2015 allowing U.S. companies and citizens to use moon and asteroid resources. This is one way in which governments work often in tandem with private industries such as SpaceX and Blue Origin. This partnership is important as the United Nations and Space Law Treaty states that space is free for all nations to explore and sovereign claims cannot be made. In short, a country cannot claim ownership in space, but the language does not preclude private industry from doing so. Additionally, there are many universities such as the University of Colorado Boulder, the California Institute of Technology, and Arizona State University that work under government grants to answer some of the most pressing and difficult questions. Lastly, there are non-governmental organizations that focus on particular issues such as equity or environmentalism to keep policymakers to task.
This sounds like a great idea, right? We think so. But as is the case with all technological development, we know that there will be societal issues that develop in tandem. For example, who gets to decide what percentage of space we should responsibly mine? How do we all come to a global agreement? Will we create man-made irreversible damage in space? Also, how will this affect the average person? While some players may make profit, what impact will it have on the global economy? The large companies leading in the field are associated with a few large countries. Will this inflow of resources only further the divide between the economically wealthy and economically poor countries? Are there ways to avoid this? Will companies supported by governments find themselves in an arms race among one another, eager to accumulate as quickly as possible, leaving less time to be thoughtful about the design of this system and potential harm? Lastly, what does this mean for our future? We are on a small planet with limited ability to explore. What will it mean to open up access to greater resources? Are we really limited by actual resources or merely our ability to acquire them?
So now that you know about asteroid mining, how can you get involved? First, check out the rest of this learning module. ASU's School of Earth and Space Exploration makes public engagement a top priority, offering tours, regularly scheduled astronomy shows, and an annual open house. Second, we hope that you realize that space enterprise is not an issue limited only to scientists and astronauts. This is a global technology with global consequences, which means we need economists, lawyers, social scientists, engineers, and so on to ensure that we are looking at this problem properly. So don't write off areas of study that don't seem like an immediate fit. We need your input too. Lastly, speak up and stay involved. Most of these ventures are tied to public funding, so let your representatives know if you have concerns or ideas. We often think of technology moving in an organized linear model, which assumes that technologies have roots in basic research, where scientists at elite research labs uncover facts and then industry or government agencies such as NASA will use them to solve real-world problems. The reality, however, is far more complex and interesting. So next time you look to the sky or watch the next SpaceX launch, remember that the choices we are making for space now will help design our society's future.